Sound. Introduction. Sound plays an important role in our lives. It is medium of communication for all of us. Even animals also make use of sounds to communicate with each other. Every day, we hear a variety of sounds in our surroundings. Some of these sounds are pleasant, while some are unpleasant. Example: sounds like bird calls and music are pleasant sounds, and honking of vehicles and machines are unpleasant. Production of sound. Sound is a form of energy that travels in the form of vibrations through the air or another medium. It is this energy that gives us the sensation of hearing. Sound is produced by a vibrating body. A vibrating body produces sound in the form of waves. Example: waves are produced when a string of guitar is plucked. As a result, string starts moving back and forth, and the sound is produced as a result of vibrations. The back and forth or to and fro motion in a body is termed as vibration or oscillation. There are many examples of vibrating bodies, such as musical instruments, drum or tabla, stretched animal hides, guitar or sitar, stretched strings, flute, and air column. The sound we produce is also the result of vibrations caused by our vocal cords. Sound requires a medium for propagation. The movement of sound through a medium is called propagation of sound. Sound cannot travel through vacuum. It needs a medium through which it can travel. It can travel through mediums like solid, liquid, and gases. However, it travels faster in solids than in liquids and faster in liquids than gases. Here is an activity to show that sound is produced by vibrations. Take a tuning fork, rubber pad, and a beaker of water. Strike the tuning fork against the pad and touch the surface of water. You will notice that the waves are produced in the water due to the vibrating fork. As vibration is produced by the tuning fork, a humming sound is also produced. Thus, it is clear that vibrations produce sound. The denser the medium, the faster the sound will travel. The propagation of sound happens in all directions in a medium. Speed of sound. The speed of sound changes with the change in medium. Speed also depends on the density and temperature of the medium. At higher temperature, the speed of sound is higher, while at lower temperature, the speed decreases. The higher the density of the medium, faster will be the speed of sound. The speed of sound is maximum in solids. 5,920 meters per second in steel, lesser in liquids. 1,480 meters per second in water, and minimum in gases. 330 meters per second in air. Here is an activity to show that sound can travel through a solid medium. Keep one of your ears against one end of your desk. Close the other ear firmly with the palm of your hand. Tell a friend to tap the desk at the other end with his hand as shown in the figure. You will be able to hear the sound loud and clear. Characteristics of vibrations. Vibrations are produced rapidly in all the directions, so it is not easy to observe them clearly. To study their characteristics, vibrations are produced in slower rate by using the arrangement termed as simple pendulum. We can make a pendulum by using a bob and a string. When the pendulum is at rest at position A, we call it mean position. When it is moving, it oscillates between the position B and C, which are the extreme positions. The distance AC and AB is called amplitude. Amplitude of a vibration refers to the maximum distance moved by a vibrating body from mean to extreme position. Frequency. The total number of vibrations taking place in 1 second is said to be its frequency. Frequency is measured in hertz. Example, if the pendulum makes 10 oscillations every second, its frequency will be 10 hertz. Time period. Time period refers to the time taken by the pendulum for one complete oscillation. It remains same as long as the length of the pendulum does not change. Time period is equal to 1 upon frequency. Time period is measured in terms of seconds. Here is an activity to show that a medium is required for the propagation of sound. You need an alarm clock, airtight jar, and a vacuum pump. Set 5 minutes alarm in the clock. Then place it inside the bell jar. You will hear alarm sound. Now remove all the air from the bell jar with the help of a vacuum pump. Again, set the alarm and keep it inside the bell jar. Wait for the alarm to ring. You will not hear alarm this time. It shows that when air is removed, sound is not heard. This is because the sound can't travel through vacuum. It means that sound needs a medium for the propagation of sound. How we produce sound. The organ in human beings that is involved in the production of sound is the larynx, commonly known as the voice box. The voice box is situated in the neck at the upper end of the windpipe. The sound produced is controlled by vocal cords. The vocal cords are the thin bands of tissues stretched across the voice box in a way that there is a narrow slit between them for air to pass. The vocal cords vibrate when air from the lungs is forced through the slit. The sounds of higher frequency are produced in women and children because they have smaller vocal cords. How we hear sound. When the sound waves reach our ears, we hear the sound. The human ear can be divided into 3 main parts, that is, external ear, middle ear, and internal ear. External ear. The external ear, or pinna, appears like a funnel. Its function is to catch sound waves and to direct them towards middle ear. Middle ear. The middle ear is composed of a stretched membrane and 3 small bones. The stretched membrane is called the eardrum and small bones are called bony ossicles. These are named sequentially from outside to inside as malleus, incus, and stapes. When sound waves come to the middle ear, it sets vibrations in the eardrum. After that, sound waves are transferred from eardrum to the 3 bones. Internal ear. The internal ear is composed of cochlea and semicircular canals. cochlea appears like a snail from outside. Vibrations from middle ear reach the cochlea. Signals from cochlea reach the brain through the auditory nerve and we hear a sound. Semicircular canals have no role in sense of hearing, rather they maintain the balance of the body. Characteristics of sound. We hear different types of sound. What is it that differentiates one sound from the other? What are the characteristics of sound? Let us understand these. Amplitude. It is the loudness of sound. It refers to the amount of pressure exerted by the sound source on the molecules of air. It is the measure of how high a crest is or how low a trough is. The highest part of the disturbance on a wave is termed as crest or peak. The lowest part of the disturbance on a wave is termed as trough. Frequency. Frequency refers to the number of vibrations made by the particles in 1 second. Frequency is measured in hertz. Pitch. The shrillness of a sound refers to its pitch. It depends on the frequency of vibrations. The higher the frequency, more shrill is the sound. Generally, a woman's voice has a higher pitch than a man's voice. Wavelength. Wavelength is the length between two consecutive peaks, crest, or two consecutive valleys, trough of a wave. Wavelength is represented by Greek letter lambda. Louder sound has shorter wavelength and softer sound has longer wavelength. The SI unit of wavelength is meter. Quality. The quality of sound is a property by the virtue of which two sounds of the same pitch and loudness can be distinguished. Various studies show that most vibrating objects do not generate sound of just one frequency. Example, the sound produced by a veena is different from the sound of the same pitch and loudness produced by a sitar. Audible and inaudible sounds. We know that we need a vibrating body for the production of sound. Sounds of frequencies less than about 20 vibrations per second, 20 Hz, can't be detected by human ear. Such sounds are called inaudible. On the other hand, sounds of frequencies higher than about 20,000 vibrations per second, 20,000 Hz, are also not audible to human ear. Thus, for human ear, the audible range is roughly from 20 to 20,000 Hz. Sounds of a frequency below 20 Hz are called infrasonic, and those of a frequency above 20,000 Hz are called ultrasonic. Though we can hear sounds between 20 to 20,000 Hz, we can produce sounds within a range of only 60 to 13,000 Hz. Supersonic. This refers to the speed of a body in reference to the speed of sound in air. When an object, such as a jet aeroplane, moves faster than the speed of sound in air, it is called supersonic. Noise and music. Noise is that sound which is unwanted and unpleasant to ear. A noise generally has no repeated pattern. It is disorganized sound. On the contrary, any sound that is repeated in a pattern and is organized is said to be music. Noise pollution. The presence of excessive or unwanted sounds in the environment is called noise pollution. The major causes of noise pollution are sounds of vehicles, explosions including bursting of crackers, machines and loudspeakers, television, radio at high volumes, some kitchen appliances, desert coolers, air conditioners all contribute to noise pollution. Noise pollution may result in many health-related problems like lack of sleep, hypertension, and anxiety. A person who is exposed to loud sound continuously may get temporary or even permanent impairment of hearing. The loudness of sound is measured in decibels, dB. The loudness of different kinds of sounds in decibels is given in the following table. Normal breathing 10 decibels, soft whisper 30 decibels, normal conversation 60 decibels, busy traffic 70 decibels, average factory 80 decibels. Above 80 decibels, the noise becomes physically painful. Measures to limit noise pollution. To control noise, we must control the sources of noise. For this, silence devices must be installed in aircraft engines, transport vehicles, industrial machines, and home appliances. All noisy operations must be conducted away from any residential area. Use of automobile horns should be minimized. Television and music systems should be played at low volumes. Trees should be planted along the roads and around the buildings to cut down the sounds reaching the residents, thus reducing the harmful effects of sound pollution. Reflection and absorption of sound. Sound can be reflected and absorbed. These properties of sound have many applications. Echo. You may have heard echoes in long corridors or large empty halls. Echo is a reflected sound. The bouncing of sound is like the ball bounces back to the wall. Although sound is reflected all the time around us, but we can't hear echo all the time. It happens only when we are at a certain distance from the reflecting surface. Our ears can hear echo only if it reaches our ears about 1/10 of a second after the first sound is produced. Most of the things around us, like wood, clothes, and furniture, are poor reflectors and good absorbers of sound. Had this not been the case, our voices would be reflected again and again from walls and floors, making it difficult for us to converse. Applications of echoes. Echoes are used to locate underwater objects and measure the depth of the sea by instrument called sonar radars. Vibrations are sent down from ships. The time taken for reflected vibrations to return helps in calculating the depth. Doctors use echoes to get pictures of internal organs of the body. Ultrasonic vibrations reflected by different parts of an organ help to create an image of the organ. This technique is called endocardiography in case of heart. In the case of other organs, it is termed as ultrasonography. Bats use echoes to locate their prey. They use ultrasonic vibrations and can judge the distance of the prey from the time taken by echo to return. Sound absorption. When sound waves hit a surface, some of them are reflected and some are absorbed. The walls absorb part of the sound produced and cut down on the amount of noise. Example, the walls of hospitals, auditorium, school. Musical instruments. You know that plucking a rubber band produces a sound. But do you know that the pitch of the sound produced may be changed by varying the extent to which the band is stretched? Most musical instruments are based on this principle. Broadly, musical instruments are classified into the following categories. In stringed instruments, sound is produced by a vibrating string. The shrillness or pitch of the sound is altered by changing the length of the vibrating portion of the string. Example, a guitar player plucks the string with the right hand, while the pitch of the sound produced is changed by pressing the string with the left hand on the fret. Some other examples of stringed instruments are sitar, veena, violin, and sarod. In wind instruments, sound is produced by vibrating air column inside the instrument. The pitch of the sound is altered by changing the length of the vibrating air column. Example, flute, shehnai, harmonium, mouth organ, and clarinet. In percussion instruments, sound is produced by a vibrating skin or membrane. The pitch of the sound is altered by increasing or decreasing the tension in the membrane. Example, tabla and drum.